Hi again. So now that we've talked about the three-read strategy, we are going to apply that to a situation and find the equation, graph, and table for that situation. So let's read the situation that I've been given. Joe is selling tickets to a school play. An adult ticket costs $10 and a student ticket costs $5. Joe sells both adult tickets and student tickets and sells 50 tickets per performance to fill up the theater and raises $300. What are the two equations that can be created from this problem? So, if I'm reading the problem 3 times because of my 3-read strategy, I know that my first read should be what the problem is about. So in reading that situation, I know that this problem is about a boy named Joe who's selling tickets to a school play, and that he is trying to fill up the theater, and he's selling both adult tickets and student tickets. So I'm going to read this problem again, and I am going to find what the question is. So Joe is selling tickets to a school play. An adult ticket costs $10 and a student ticket costs $5. Joe sells both adult tickets and student tickets and sells $50 tickets per performance to fill up the theater and raises $300. What are the two equations that can be created from this problem? So there it is. There is our question. I'm going to highlight that. Third read. What information is important? So Joe is selling tickets to a school play. An adult ticket costs $10. This is important for sure. And a student ticket costs $5. That is also important. Joe sells both adult tickets and student tickets, so we know that. And he sells 50 tickets per performance to fill up the theater and raises $300. So that is also very important. So now we have our important information highlighted in red and our question highlighted in yellow. So now what I want to do is I want to write an equation from what I know is important in this situation. Because I've pulled that out, I used my 3-read strategy, which is also part of my thinking like a mathematician that we talked about the other day. And now I can go ahead and I can write an equation. So, let's see here. An adult ticket costs $10 and a student ticket costs $5. So I want to, I'm going to make X equal adult ticket. Adult ticket. And student tickets are going to be Y. Okay, so that'll make it easy on me. So, if an adult ticket is $10, so 10x, and the student tickets, we know we're adding them because it says he sells both adult tickets and student tickets, and he sells 50 tickets per performance to fill up the theater and raise $300. So, when it has the money signs, we know that those equations are going to go together. So $10 plus $5 tickets each are gonna, so we're going to say, because he raised $300, so each $10 adult ticket, each time he sells one of those, and each time he sells a $5 student ticket, those are all going to combine, and he's going to raise $300. So I can make that equation there. So, individually, let's say, X plus Y, so student tickets plus adult tickets plus student tickets, and he says he sells 50 tickets per performance. So that is going to equal 50. So that important information got pulled out, and I was able to make my two equations right here. So now I have them written on the next page. Let's see if we're correct. Perfect. X plus Y, so adult tickets plus student tickets. Joe sold 50, and the adult tickets were $10, student tickets were $5, and altogether he made $300. So now if I'm graphing this, we know we have to look for the intercepts, which are X and Y. And we know that we have to look for rate of change. So I am going to show you the graphs just because then I can explain it a little better and we can go from there. So x plus y equals 50. So if I was going to make this, so I would actually, let's see if I can type down here. So I would actually subtract the y equals 50 minus x, just because that is standard form. So if I were to put in a 0 here to get the y-intercept, I would know that's how we get the y-intercept on when x is 0, so it'd be y equals 50. So let's look at our graph. And we have y equals 50. And we can then, if we put in a 0 for y, we're also going to get a 0, or we would also get a 50 for x. So we know that this graph is fine. This line is x plus 50, or x plus y equals 50. And your rate of change right here. Okay. So 10x plus 5y equals 300. We would have to do some subtracting here again and dividing. So we'd have, let's see, I'm going to actually bring this up here. So this, I'm going to have 5y equals 300 minus 10x. Then I'm going to divide everything by 5. So 300 divided, so then I can have y alone. So 300 divided by 5 would be y equals 60 minus 10x. So perfect. And this, how I had that rate of change, I didn't explain that for the last one, that slope, was because this is minus 1, and this is also minus 1 right here, that rate of change. So, if I go back here, I can see 60 minus 10x. So here is y, because if I put in a 0 there, it's going to leave me there with that 60. So there is my y-intercept. If I wanted to find my x-intercept, I put a 0 here, and that would give me that 30. And then if we wanted the slope, it would be negative 10, obviously. So go here, and we'd get that because 60 over 40 equivalent. Okay, so now let's look at the table. And the table is honestly just copying everything from the graph. So we could see the same thing we already found. We can see that this is going down by 10. This is going down by 20. So there we go, and we can see clearly that that is correct.